Let's start the recording. Okay, so the weekly announcement I put in on our homepage in Eagle Online. And it just gives you a reminder of like kind of stuff that's going on. And then the due dates, just so they're posted somewhere. So in case I forget to go over them in class, we have them there. So we've got our announcement in here. So I just want to share that. Because again, if you hadn't had a chance to see it, I just want to go through it so you know what I'm talking about. So you can see here it says week 3. Welcome to week 3. This week you have your homework due as well as your first quiz. Your quiz is due tomorrow on Tuesday, and you need to take it in person in the FMC. If you're on COVID quarantine and can't come to campus, let me know. Also, if you need to take it on the Libby campus, I need to know today so that I can make sure that the paper quiz gets sent up there for you.
Is that the same place where we went to take our placement test?
Yes, exactly. And then what's due to this week, we've got homework 1.3 through 1.5 due tonight. And then, like I said, quiz 1, which is over sections 1.1 through 1.5. So if you want to review and look over your notes and your homework assignments for that section, or those sections, I should say, that's a good way to study. And then you've got homework 1.6 and 1.7 due on Wednesday. So I'm going to go over 1.6 and 1.7 today. And then, like I said, the homework for those sections are going to be due on Wednesday. So any questions for me before we get started? Okay. Well, we are in our notebook on page 16. So I'm going to go ahead and change my sharing. And so we can see that we're talking about 1.6. So now we're starting to, we talked about addition, subtraction, multiplication, and division with whole numbers. And now we're getting into solving equations using those numbers. Okay, so a variable is a symbol, usually a letter, that stands for a value that may or may not vary. That not may or may not, just may vary. So things to know about those symbols, obviously normally letters, letters that we don't use for variables is the letter I, because I is a number. It's called an imaginary number, and it's equal to the square root of -1. We're not going to get into that in this class, but I just want you to know why we don't use the letter I. We also don't use the letter E, and the reason is that E is a representative of a number as well. And so it's related with natural logarithms. And again, something we will not get into in this class, but I just want you to know why. And then the last one that we don't use is O, and that's because of the fact that it looks like 0, right? So that just makes it more confusing. So those are the 3 variables you won't see us use to represent variables. Those are 3 letters, excuse me, that you will not see us used to represent variables. So an equation is a mathematical statement that equates to mathematical expressions. And really, this means it has an equal sign. That's what makes it an equation, because it's got one side that's on one side of the equal sign, and then the equal sign means that it is equated to what's on the other side of the equal sign. And then what does it mean to be a solution? So a solution of an equation is a numerical value that satisfies the equation. That is, when the variable in the equation is replaced by the solution, a true statement results. And we'll talk about that more once we actually get into solving these equations. So some basic ways to solve equations. So we can add the same quantity to both sides. So you can see if A equals B, then adding the amount C to both sides doesn't change the value of A and B. Or you can subtract the amount from both sides. So, and then addition and subtraction is inverse operations. So the inverse of addition is subtraction. If we start with the number X and add a number A, and then subtract a from the result, we'll get back to the original. So let's say we had x plus 3. Well, when I subtract 3, it's just going to equal x, because adding 3 and subtracting 3 cancel each other, and that's why we're left with just x. And then the inverse of subtraction is addition. And so if we start with the number x and we subtract a number a, adding a to the result will give us the original value back. So if I had x minus 2 and then I added 2, the plus 2 cancels out the minus 2. And again, we're just left with x as our answer. So I think these make more sense when we're actually trying to, we're looking them in the situation. So if we go to the next page, we've got this first problem that says x plus 5 equals 6. So if we think about this let's think about it in terms of like manipulatives. So let's say we have our variable x, and then we have the 5. So we've got 1, 2, 3, 4, 5 of them. And that is equal to 1, 2, 3, 4, 5, 6, right? So I want to take 5 away from both sides. So if I take 5 away, I'm going to go 1, 2, 3, 4, 5, and take them away from the other side, 1, 2, 3, 4, 5. And what am I left with in purple? Well, I'm left with x equaling 1. So if I think about this in terms of the operations, say if x plus 5 equals 6. So remember on what we just talked about is if we take an amount away from both sides, it keeps the equation balanced. So from here, I want to take 5 away from both sides. I like to do this vertically because for me, it keeps my work more organized. You could also write it this way though. We could have x plus 5, and then we're going to take 5 away, and that's equal to 6. Take 5 away. The reason why I like doing it vertically is that in the horizontal method, you have to have extra room to make sure you can put in that minus 5 on both sides. And honestly, for me, I just don't feel like making sure I have the space. Again, that's just me. So we're going to solve this. If I have plus 5 minus 5, these are going to cancel. I just bring my x down. 6 minus 5 is 1, and we can see that x equals 1. If I was solving it the right-hand way, again, this plus 5 minus 5, those cancel with each other, giving me x equals 6 minus 5, or x equals 1. So again, what we're doing there is we're doing the opposite of plus 5. So that's why we are subtracting 5. So why don't you try number 2 and tell me what you think the answer is. So if we look at this, we have x plus 7 equals 26. So we have some number that when we add 7 to it, it's got to equal 26. So undoing that, we need to subtract the 7. So we'll bring our x down. And if I have 26 minus 7, that gives us 19. And then remember how we were talking about if it's a solution, you can plug it back in and it'll satisfy it. Well, let's check. So we do a check. I'm going to say 19 plus 7, and does that equal 26? We'll simplify on the left-hand side. 19 plus 7 is 26, which equals 26. So we get a check, and that is a true solution then. So in 1 and 2, we had plus a variable plus a value, so we had to subtract from both sides. And now number 3, we have it minus a value. So in order to undo that subtraction, we want to use addition. So x minus 6 plus 6, and minus 6 plus 6 cancel, giving us 11 plus 6, or 17. Okay. Again, if we think about this in terms of some number minus 6 has to equal 11, so the only number that can be is 17. So I want you to go ahead and try 4, 5, and 6 on your own and tell me what you think the answers are. Okay, looking at number 4, I have 17 equals 12 plus x. We can also rewrite this as 17 equals x plus 12, because the x is positive, the 12 is positive, so we're adding them together. I think rewriting it is helpful because it can be confusing based upon what's written on the left, how you want to go about solving this. But because we know the 12 is positive, we're being added on, we need to subtract 12 from both sides, bring our x down, and x is equal to 5. Okay. In number 5, I got 5 equals x plus minus 23. So again, to undo that subtraction of 23, we want to add 23 to both sides. We'll bring our x down. These cancel, and 5 plus 23 equals 28. And then our last one is 8 equals x minus 4. Again, to undo that subtraction, we need to use addition. So we're going to add 4 to both sides, bring the x down, and 8 plus 4 is going to be 12. So we get x equals 12. All right, so if we have to solve them with addition and subtraction, we're also going to have to solve them using multiplication and division. So this is where we go to with 1.7. So in 1.7, how can we solve these equations with multiplication and division? So again, the same setup is that if you have A equals B, then if we multiply both sides by a value C, we're going to have A times C equals B times C. And this is true when C is not equal to 0, okay? The reason why we can't allow C to equal 0 here is because if A and B were not equal and we multiplied them both by 0, we would get an equal statement. And so again, in order to assume, to set up the situation where A and B have to be equal to each other, we have to say that C can't be 0. And then with division, if I have A equals B, if I divide both sides by C, they're still going to be equivalent, but again, C cannot equal 0. So the inverse of multiplication is division. So if we start with a number X being multiplied by a number A, then dividing the result by the number A results us to the original number X. So here's what they're saying. If I have 2 times X and I divide this amount by 2, the 2's will cancel and I'll just be left with X. The same is true for division, right? The inverse of division is multiplication. So if we start with some value X divided by a value A, then multiplying the result by the number A returns us to the original number. Again, these written out explanations can be confusing. Let's look at an example. So if I have X divided by 3 and I times this by 3, and specifically it's going to be times by 3 over 1, this causes these 3's to cancel and I end up with just X as my answer. So let's put this into practice. So number 1, it says 3 times X equals 6, meaning 3 times some number equals 6. So in the beginning, it's easy to do these in our heads because we'll think, oh, well, 3 times 2 equals 6, so X has to equal 2. But I want you to get into the habit of actually showing your work because they're going to get more complicated. We're going to start doing multiplication and division, addition, or multiplication and subtraction, division and addition. We're going to start combining all of it. And so you want to show your work so you're getting in a good habit from the very beginning. So here's what I'm talking about. If we have 3 times X equals 6, we want to undo that multiplication, we need to divide. And specifically, we need to divide by the number X is being multiplied by. And if we do it to the right, to the left-hand side, we got to do it to the right-hand side as well. So 3 times X divided by 3, these 3's cancel. And I'm just left with X divided by 3, which reduces to 2. So go ahead and do 2 and 4 and send me your answers. Okay, so for number 2, we'll divide both sides by 8 and X equals 7. And number 4, we'll divide both sides by 4 and X equals 6. So 2 and 4 were both multiplication problems that we solved with division. And therefore 3, 5, and 6 are division problems that we're going to solve with multiplication. So you can see I have x divided by 7 equals 7. So we want to solve for x because it's being divided by 7. We need to undo that division with multiplication, meaning we're going to multiply both sides by 7. These will then cancel, and we'll be left with x equals 49. This is a good place to check your work to make sure that you actually divided by the right amount. So again, the check here is 49 divided by 7. Well, that equals 7, so we're good, right? 49 divided by 7 is 7, so we're okay. So go and do 5 and 6, and then we'll talk about them. Okay, so number 5, we're going to multiply both sides by 6, giving us x equals 54. In number 6, we're going to multiply both sides by 12, giving us x equals 36. Okay, so we've got word problems. I know, they're everybody's favorite. It's going to be fine. So page 20. We've got some suggestions for how to set up a word problem to solve it. So first of all, set up a variable dictionary. What this means is you want to define your variables and write it out. So statements such as let P represent the perimeter, or labeling unknown values with variables in a table, and labeling unknown quantities with a sketch or a diagram, just something to give you an idea, a visualization of what it is these variables mean, right? So set up an equation. Every solution to a word problem must include a carefully crafted equation that accurately describes the constraints in the problem statement. All constraints mean is like, it has to fit the situation, okay? And I'll talk about that more when we actually get into an example. Then you got to solve it, right? Clearly, we're trying to solve it. And then you have your answer. This step is easily overlooked. So for example, the problem might ask for Jane's age, but your equation solution gives the age of Jane's sister Liz. So you want to check back and make sure, did you actually answer the correct question, or is there something more that you need to do? And then again, you want to look back and does your answer make sense based upon the words in the original statement? So let's put these into action. Let's see if I can Just scroll out just a little bit so we can see the instructions and also do the problem. So number 3 says 3 more than a certain number is 19. First of all, more than means addition, and the word is the equal sign. So if we read this, more than a certain number, so 3 more than a certain number, and that's your variable. And let's just use X because it's everybody's favorite. 3 more than a certain number, X, or the variable, is 19. And then it says find the number. So we're diagramming the sentence here by writing it out as an equation. So we know that a certain number is equal to X. We set up the equation, and when it says the constraints of the problem, the constraints were it had to be 3 more than, so that's the addition, and then it has to equal 19, okay? So go ahead and solve for X and let me know what you get. All right, good job, everyone. So X does in fact equal 16 because if we subtract 3 from both sides, we get 16. So when we look at number 2 says 19 less than a certain number is 1. This is a place it's really easy to make a mistake. Because it says less than a certain number, this statement less than a certain number is going to indicate we want to do X minus because it's less than that amount. So we're taking the amount, lessing 19, and it has to equal 1. So if you want to write in your notes somehow that when we see this statement less than a certain number, I want you to automatically think X minus. Because then we're doing X minus that 19, and it's going to equal 1. So if we solve for X, we'll add 19 to both sides, bring the X down, and we get 20. Going back to number 1, we could have set up the problem as X plus 3, meaning 3 more than that value equals 19, and we still would have gotten the same answer. If it's helpful to always write your variable first and then the addition or subtraction afterwards, that's going to help you to be consistent and not have as many opportunities to be confused. Because again, I can't tell you how many times I've seen less than a certain number and students write 19 minus, and it needs to be X minus 19. Okay. So questions about number 2, because it's a confusing one, I know. Go to the next page. So number 3 says a triangle has a perimeter. So remember, as you're going through these, define some of your terms. So remember, perimeter is the distance around. And which means add all the sides. So the perimeter of 55 feet also has 2 sides that measure 14 feet and 13 feet respectively. Find the length of the third side of the triangle. So this is an example where drawing a picture is going to be helpful, or a diagram. So if I have a triangle and it says 2 sides, one is 14 feet and another is 13 feet, we need to find the length of the third side, which we don't know. So we're just going to call it Y. Change up your variables or else it gets really boring, right? So going back, it says the triangle has a perimeter of 55 feet. So remember to find the perimeter, we're starting here. We're going to go down one side, turn and go down the other, and then turn and go up the third. Meaning if we add the 3 side lengths up, it's got to equal 55. So go ahead and solve for y. Okay, so there's 2 ways we can go about solving this. We can combine the like terms first, meaning the plus 14 and the plus 13. If we add those together, we can simplify this to y plus 27 equals 55. Then we can subtract 27 from both sides, bringing our y down, and 55 minus 27 is 28. You don't have to add those together first though. So if you wanted to, the alternative here is that if I have y plus 14 plus 13 equals 55, we can subtract them off each, meaning I could do minus 13 first, bringing this stuff down. So I still have y plus 14. On the right-hand side, 55 minus 13 is going to be 42. And then we can subtract 14 from both sides. And 14 or 42 minus 14. So remember, we have to borrow. So 12 minus 4 is 8. Because I borrowed, I'm left with a 3 here. 3 minus 1 is 2. And they end up with y equals 28, which obviously doesn't make sense in terms of our diagram, but it's just a diagram, right? So that means that y is equal to 28 feet. Personally, I prefer to combine like terms. That's what it's called when we add the 14 and the 13 up. I like to get those together before I subtract because personally, I'm better at adding than subtracting, meaning I'm more likely to make a mistake by subtracting a value off than I am by adding the values together first. So personally, this method would allow me to make more mistakes because we're doing this by hand, right? Than doing it the blue way where I first add 14 and 13 up and then subtract that off. All right. So Mercy withdraws $430 from her bank account. As a result, the new account balance is $1,200. Find the account balance before the withdrawal. So I'm going to let you try this one on your own. Define your variable, write an equation, and solve it. You only have to send me your answer, what you get for your variable, okay? Okay, so Mercy withdraws $430 from her bank account. So let's just think about this first statement. Okay, so she's got some amount and she's withdrawing $430 from it. As a result, the new balance is $1,200. So you can think about it as old minus 430 equals new, right? So in order to solve this, we're going to use addition. We're going to add 430 to both sides, giving us x equals $1,630 as her balance before she made the withdrawal. All right, number 4 says 5 times an unknown number is 35. So again, the word times means multiply. And we can represent that with parentheses, a dot, okay? I don't like to use the little this because now that we're starting to deal with variables, it gets confusing if we have the x to mean multiplication. Or you can just write the number in front of the variable, meaning we're gonna have 5 times an unknown number. Let's call it m, why not? Remember the word is equal to 35. So we've got 5 times m equals 35. We can divide by 5 on both sides. It's going to cancel that 5 out on the left. 35 divided by 5 is 7. So number 6 says when an unknown number is divided by 9. So an unknown number divided by 9. So this part right here means 9 on the bottom because we're dividing by 9. So the value that comes after the word divided by is what goes in your denominator, meaning unknown number, let's call it, I don't know, C. When it's divided by 9, the result is 2. So some unknown number C divided by 9, and the result is 2. So again, to solve this, we're going to multiply both sides by what we're dividing by, meaning we're going to multiply both sides by 9, giving us C equals 18 as our answer. Any questions about 4 and 6 before we move forward? Okay. So number 7 says the area of a rectangle is 55 square centimeters. So remember, area means length times width. So if we have a rectangle, we've got a length and a width. So if the length of the rectangle is 5 centimeters, so we can come in here and replace this L with 5 centimeters, find the width of the rectangle. So remember, to find the area, we're going to multiply 5 times W, and that's going to equal 55. So then to solve for W, we will divide by 5, and we get a width of 11. And then remember, we have to think, oh, what does it mean in terms of our problem? Well, it means that centimeters. So again, it's okay if you make a drawing, you're like, well, Erin, this looks weird. Your 5 on your length is a longer looking side than the answer, which is 11. But again, I'm just making a drawing so that I have placeholders to give myself a visualization. Obviously, my drawing is not going to be accurate or to scale, okay? So with area, you've got to remember what it means to find the area of a rectangle. And that means we're taking the length and we're multiplying it by the width. Or you can say the length times the width. I just got done saying don't use X to represent multiplication. And then what do I do right there? I write it as multiplication. But you know what I'm trying to say. We're multiplying L and W. And then finally, number 8 says a class of 44 students averaged 88 points. So the word average means that we're going to end up dividing. And when you find the average, that means the total points divided by the total students. And that's going to equal your average. So again, there's some terms here that if you don't know what they mean in terms of the problem, you're not going to be able to set up the problem, right? So we have to understand what the word average means. And again, it's taking your total points and dividing it by the total number of students you have. So knowing how to set that up, I want you to try this one and tell me what you get as the answer, okay? So remember, we're solving this equation that I've set up right here. And so what that means is that I have the average, which is 88 points, is equal to the total points, I don't know, over the total number of students, which is 44. So think about solving for P there. So we've got the average 88 is equal to a total number of points divided by 44. So since our variables in the numerator, and when we're monitoring the validity of our answers, again, if the number's in the numerator, that means it needs to be bigger than 44 if we get a whole number 88 as our answer. So when solving for P, I'm going to multiply both sides by 44. This is going to cause this division of 44 to cancel. And I get 44 times 88, which is 3,872 points. Okay. So again, as you're doing these, there's relationships like this that you need to know. So this would be one of those relationships, this average equals total points over total students that you want to write down. And then when you're looking at the problem, you want to plug in the pieces that match that. So just remembering, how did we come about this? So we know that total points over total students equals the average. Well, in our problem, it says total students are 44, and the average was 88. So plugging these amounts in, we plug the 88 in for the average, the 44 in for the total students. So again, we're looking at, well, what's missing? Well, what's missing that I don't have an arrow drawn to is total points. So I just said P, you can use T, you can use L. I do not care. It's your variable. Shoot, you could draw a flower there and use that. All a variable is a placeholder, and it's something you're solving for, okay? So that's how we get with the P over 44 equals 88, okay? So that one's kind of hard. So any questions about 7 or 8 there? Okay, so that is the end of chapter 1. So like I said, you're going to have homeworks 1.6 and 1.7 due later this week. So the assignments for those, so 1.6 is going to be 1 through 61, every other odd. And then 1.7 is going to be 1 through 53, every other odd. Okay, so just a reminder, you've got homeworks 1.3, 1.4, 1.5 due tonight. You have quiz 1 due tomorrow, and then homeworks 1.6 and 1.7 due later this week. When did I say those were due? They are due Wednesday, okay? So lots right at the beginning of the week, and then you get to relax for the rest of the week, okay?
Thank you.
Yeah, have a good couple of days, and I'll talk to you all on Wednesday, okay?
You too.
Thank
Bye.
you.